Hello students, so now we are doing the recurrence relation. Recurrence relation for Laguerre polynomial is developed from the generating formula, which is this summation ln t raised to power n, where n vary from 0 to infinity, is equal to e raised to power minus xt upon 1 minus t upon 1 minus t. What we have to do to get this first recurrence relation, we have to differentiate both sides with respect to t, right? If we differentiate with respect to t this relation, then we'll get ln as it is, because it is a function of x. Derivative of t raised to power n is n t raised to power n minus 1. On the other hand, the derivative of this function, it contains two terms of t, so here we will use the product rule of differentiation with respect to t. So first of all, we take the derivative of this function, which is 1 upon 1 minus t square. Derivative of this is 1 upon v type of formula. Then e raised to power minus xt upon 1 minus t as it is. Now we keep this function 1 minus t as it is, and derivative of this will be e raised to power minus xt upon 1 minus t into derivative of x upon xt upon 1 minus t. Minus of this derivative will be 1 minus t whole square, and if you solve this, this will be x. Minus x and minus will make this sign minus, because the formula of derivative of product of two functions is derivative of one, second as it is, then first as it is, derivative of the second. Here it is the plus sign, so this is minus because x is of negative sign. So this is what we get from here. Now can just we take 1 minus t, which exists in both this, common. It is e raised to power minus xt upon 1 minus t upon 1 minus t. One power is here. On the other term, we have x here and 1 minus t whole square, right? After taking 1 minus t common from here. Now we put the value of this, which is summation ln t raised to power n, where n vary from 0 to infinity. Here also keeping x on 1 minus t as it is, and the rest of term will become the generating formula. So now we take this 1 minus t and also this one. We take more 1 minus t common. So it is 1 upon 1 minus t square here, and this is 1 minus t into summation ln t raised to power n minus x into summation ln t raised to power n. Now we take this to the other side. This is what we have after taking the term 1 minus t square on the other side. Now we open this square. This is 1 plus t square minus 2t, which will be multiplied with t raised to power n minus 1 here, and this summation 0 to infinity, and ln will be as it is. Similarly, you can take this inside this summation and multiply it with the terms containing t. X we don't need to take inside the summation because we have to compare the powers of t here. So now after multiplying this, we get, now see in the next step what we have done. We multiply this n into t raised to power n minus 1 with each of the term in the bracket here also, and all the other things are same. Now this summation ln into n is multiplied with each term in the bracket, and we get 3 summation on this side. And similarly, we multiply this summation with these two terms. We get n vary from 0 to infinity ln t raised to power n minus summation n vary from 0 to infinity ln t raised to power n plus 1 minus x summation n vary from 0 to infinity ln t raised to power n. Now what we have to do, we have to compare the coefficient of t raised to power n on both sides. Then comparing coefficient of t raised to power n. So what will be the coefficient of t raised to power n here in the first term? It will be, when we put n is equal to 0, 1 to infinity, and t raised to power n will have this term n minus 1 will be n, means n will be equal to n plus 1. So this will be ln plus 1 into n plus 1, the coefficient of t raised to power n from this. And for the other term here it is n plus 1. So t raised to power n coefficient will be given if we subtract 1 from this. So it will be ln minus 1 into n minus 1. Minus 2 into, this is t raised to power n only. So this is the coefficient n into ln. On the other side it is also ln. The coefficient of t raised to power n will be obtained when n plus 1 is changed to n. Right. So this will be minus ln minus 1. When n plus 1 is changed to n, means n is changed to n minus 1. Minus x as it is, and this is already t raised to power n, and we have to take ln here. Now we have to collect all the term on one side. So now collecting this is the only term, and here are 3 terms containing ln. So we collect them here, and 2 terms containing ln minus 1, and collecting all these we get the required reconciliation here. Now this is the second reconciliation. To derive this we have to write the generating formula and differentiate this generating formula with respect to x. And if we differentiate it with respect to x, because we know that ln x is a function of x, so derivative of this will be ln dash x and t raised to power n as it is, n vary from 0 to infinity. Here also 1 upon 1 minus t will be considered constant, and derivative of this term is e raised to power minus xt upon 1 minus t into minus t upon 1 minus t, the derivative of this power. So this is what we obtained after differentiating with respect to x. Now this is summation n vary from 0 to infinity ln dash x into t raised to power n. Here also this is our summation ln x t raised to power n, that is the generating formula. Again we can put this value as summation n vary from 0 to infinity, and this term we'll keep it here, minus t upon 1 minus t. Now if we multiply this 1 minus t on the other side, we get summation n vary from 0 to infinity 1 minus t into ln dash x into t raised to power n. Here it is minus, when t is multiplied with this term, ln x into t raised to power n plus 1. Here also we have to multiply this whole term with 1 and t and separate these two summations. Now multiplying this term with the 1 and t, we get these 3 terms here. And now what we have to do, we have to compare the coefficient of t raised to power n. Now the coefficient of t raised to power n is this. In this it is coefficient of t raised to power n plus 1. We have to change n plus 1 to n, means you have to change n to n minus 1. So this will be, in this term it will be l dash n minus 1. In this term also it is n plus 1, so it will be ln minus 1. Now write these terms, we get, comparing the coefficient, it is ln dash x minus ln minus 1 dash x, and on this other side minus ln minus 1 x. So these are the terms we obtained. Now write the reconciliation 1. Here again we have to differentiate it with respect to s. We get n plus 1 into n plus 1 dash x is equal to 2n plus 1 minus x into ln dash x, and again we have to differentiate this So this is 0 derivative, it is minus 1 into ln minus n into ln minus 1 dash x. So differentiating this, we get this result, which we can now write in this way, or you can name it as number 2. We have this first result, this is number 1. Now from 1 which is ln dash x minus ln minus 1 dash x is equal to minus ln minus 1 x. So here if we have to write this value, it is ln minus 1 dash is equal to, if we take this on the other side, and it is ln dash x plus ln minus 1 x. So this is our number 3 result. So we obtained 3 result. First, by differentiating the generating formula, the result that we obtained is this one. Differentiating the generating formula, we get this thing, and then reconciliation first, and differentiating the reconciliation, we get this result. We name it as 2. This is number 3 and this is 2. Number 1 is used to get this number 3. Just this is not a different result, just rewriting the terms again. Now what we have to do, we have to replace n by n plus 1. So in this number 3, we have to replace n by n plus 1. That means where it is n, you have to write n plus 1. So this term, the first one, it will become ln, and on the other side it is l dash n plus 1, and it is again ln x. So from here we have to write this term on one side. It is ln plus 1 dash x is equal to l dash n x minus ln x. So we name this result as number 4. So what we have obtained here, now we have to see all these results closely. This is our number 2 result, this is number 3, this is number 4. What we have to do, now we have to put these values ln minus 1 dash here, right, and here from 3, right. Now this is the result of ln plus 1 dash, which we will put here. So this is number 4. So from 3 and 4 we have to put these two values in number 2. So we will write this thing. From 3 and 4, put ln minus 1 dash and ln plus 1 dash x in 2. So after using these two values here, what we will obtain? So using 3 and 4 in 2, putting these two values, we get this result. Now just we have to simplify it. Simplification means ln dash, coefficient of ln dash, here it is n plus 1 here, and from here it will be minus 2n minus 1 plus x, then from here it is plus n. So this will be the coefficient of ln dash x, right. On the other side, the coefficient of ln, which is already minus 1 here, and from here it will be plus, when we take it on the other side, n plus 1, and no more term of ln, right. Then the coefficient of l minus 1x, it is minus n here, the coefficient of ln minus 1, and there is no more term, only one term. So after simplification, what we get is 2n, n plus 1 is, n plus n is 2n, so we get only x into ln dash x. On the other side, it is n into ln x minus n into l minus 1x. So right, this is the reconciliation which we obtained. The second reconciliation is obtained here. Now quickly revising what we have done for the second recurrence relation, we write the generating formula, differentiating it with respect to x, and then we compare the coefficient of t raised to power n on both sides. We get this, we name it as number 1. We just rewrite the number 1. We take this term on one side and the other term on the two term on the other side. We get the relation 3. So again we write the recurrence relation 1, and for recurrence relation 1 we differentiate it with respect to x. First we differentiate generating formula with respect to x and get the relation 1. Then we differentiate the recurrence relation 1 with respect to x and we get this thing. We name it as number 2. Now from the recurrence relation 1, the number 1 we have named number 1. The result we get from the differentiating of the generating formula, we get this result. Here we just rewrite it, keeping this term on one side and other two on the other side. So we name it as number 3. Now in number 3, if we change n to n plus 1, we get this thing and we name it as number 4. Now we have to put these two values l n minus 1 and l n plus 1 dash, these two values in number 2. The result we obtained by differentiating the recurrence relation 1, and just putting it here and collecting the like terms will give us the recurrence relation 2. Now for the recurrence relation 3, which is this, ln dash x is equal to minus summation r vary from 0 to n minus 1 lrx. So here also we have to write the generating formula first. Generating formula is summation ln t raised to power n, where n vary from 0 to infinity, and here it is exponential minus xt upon 1 minus t upon 1 minus t. Alright, and now again we differentiate. This is generating formula. First we write the generating formula. In all the three recurrence relation, they are obtained from generating formula. Differentiating it with respect to t will get us the recurrence relation 1. Differentiating it with respect to x will give us the recurrence relation 2 and 3. And now we differentiate it with respect to x. It is summation n vary from 0 to infinity ln dash x t raised to power n. On the other side, as we have done earlier, e raised to power minus xt upon 1 minus t into minus t upon 1 minus t, the derivative. Now this is summation n vary from 0 to infinity ln dash x t raised to power n, and now again we are writing this thing as the, because this is the generating formula, but in place of n now we are going to write r. So this is summation l r x t raised to power r, where r vary from 0 to infinity. We change n to r in the case of third recurrence relation, and writing all the terms as it is minus t upon 1 minus t. Right, now this is minus t into 1 minus t raised to power minus 1. It is in the denominator. We take it in the numerator by giving the power minus 1, and summation r vary from 0 to infinity l rx and t raised to power r as it is. Now we use the binomial formula here to get this value, which is minus t into summation s vary from 0 to infinity t raised to power s. Right, the binomial expression is this. Now the other term as it is. Now combining these, so summation s vary from 0 to infinity, summation r vary from 0 to infinity, and this power of t combined power will be t raised to power r plus s plus 1. On the other side we have n vary from 0 to infinity ln dash x t raised to power n. Now comparing the coefficient of t raised to power n, it is ln dash x here. On the other side we have the coefficient of t raised to power r plus s plus 1. So we need to put r plus s plus 1 as n. If we put this, then we get s as n minus r minus 1, right? So this is the value of s, and we know that s is greater than 0. S start from 0 to infinity. So s is greater than 0, greater than equal to 0. That means this term n minus r minus 1 must be greater than 0. So it will give us the value of r. We shift r to the other side. It is n minus 1 greater than or equal to r. So this is the main part, that for this term r plus s plus 1 to be equal to n, if we take it as n, we have to put s as n minus r minus 1, or the value of r will be less than n minus 1. So in this summation, if we fix s as this, then the value of r vary from 0 to not up to infinity, r will be less than n minus 1, and it is LRX, and this we have termed as n. So for comparing the coefficient of t raised to power n on both sides, we have to take this as n. When we take this as n and keep the value of this we obtained from this relation, putting this as n, we get s. We keep it as fixed, and now the s is fixed and the r term will vary. And what will be the value of r? Because s is greater than 0, that means this term, the value of s must be greater than 0, and from this relation we shift r to the other side. R is less than n minus 1. So r will not go up to infinity, r will be less than or equal to n minus 1. So this is what we have to write here, and this minus, and we have missed this, so there will be minus sign, and this is also negative sign. So this is the recurrence relation 3.